Hi everyone, welcome back. We're going in straight into another session here. So I'd love to welcome our next speaker, Yelle, who is going to be talking a little bit more about green software, from what I understand. So again, another skew on this whole AI topic in some senses. You know, we've talked a lot of core AI, but we haven't and we've started to cover sort of all surrounding areas of AI as well. Hello, welcome. How are you doing?
I'm doing good. Thank you very much for those insightful talks today.
Yeah, no, thank you for joining us. Is this a real background? You've got a really nice view out that window.
Yeah, no, it's not real. It's
No, it's not
the office
real.
of one of my colleagues, unfortunately.
Ah, that's brilliant. No, well, it does. It was hard to decide actually. Now you say it, I feel like I can tell. There we go. Who knows?
It's the weather, right?
It's the. I was going to say. I was like, oh, that looks like a nice view. I don't think
Yeah.
it's quite like that here. Anyway, we won't take any more time from you. Could you introduce yourself to the community for us?
Yeah, of course. My name is Yelle Lieder. I'm from Germany. I'm a computer scientist by background, but my main work revolves around green IT. So I help basically everyone, especially our customers, to reduce the environmental impact of their IT systems. And a lot of my work is in AI because the software that I have developed myself was basically AI. So this is where I can help
Oh,
best.
fantastic. Love that connection that you've kind of been there, you've developed it yourself, and now obviously you're trying to help others to be a little bit more green when we're thinking about this technology. So without further ado, do we have you presenting your screen?
I will share my screen and
Fantastic.
also my slides. So you should see my slides saying Green AI now.
Yep, all good.
Awesome. So yeah, let's talk about sustainability. We want to use AI to achieve goals, and some of them might be even beneficial for sustainability. We want to build climate models to expand human capabilities to better understand the world, to make predictions about the world, and maybe even understand side effects of climate change. We want to optimize, solve problems, maybe for planning environmental protection activities. We want to use AI to forecast phenomena like in energy markets to better handle overcapacities. And we can also apply AI or machine learning to improve resilience, to predict floods and storms, to be prepared for the unavoidable effects that climate change already has today. As already said, my name is Yelle. I am a big fan and believer in AI, but I'm also a big planet enthusiast. So I want to explore together with you all how we can bring both of those worlds together, because I think AI can do good, but on the other hand, there are many aspects of AI today that actually harm our environment. At Adesso, this is my main job. I help customers reducing the footprint of their IT. We are about 10,000 people all across Europe, and we just basically a IT service provider. So why do we even need to talk about the sustainability of AI? Well, first, there are a few trends that accelerate the environmental impact of AI globally, where the first and most obvious one, we all know Moore's law, the efficiency of hardware increases and the availability of compute power increases, which together lead to decreasing cost of compute. So we use compute and thereby also AI systems more. We use them more intensively. Everyone who has a screen time app on their phone will know about that. We have a higher adoption rate in all categories of age, and we have more applications for AI systems. What used to be a simple note-taking app or text processing app is now packed with AI. And something that is especially relevant for AI is the increasing complexity. We know this overview from OpenAI, where it basically plots the complexity of models, and I think this is even accelerated. Those trends combined with the actual environmental impact happening from AI lead to the urge that we definitely need to act upon it. So let's look into the environmental impact. And people usually think about electricity and maybe carbon emission, but there's more to it. We need to talk about cooling. If you have direct cooling, which is in many areas worldwide the case, we have water evaporated onto IT equipment, which is then not available anymore at the location. We have refrigerants in data centers that have more greenhouse gas potential than carbon. And we have switchgear that also uses certain gases that leak over time and produce negative environmental impact and deplete the ozone layer. We have problems with land use due to data centers because it is just cheaper to build them horizontally instead of vertically, which leads to direct competition with urban and residential areas, but also has impacts on biodiversity. And we, of course, need to talk about the mining of rare minerals, where second-order effects also are in the social area, especially in the global south. But we see also impacts from mining in case of coal, for example, because coal also has to be mined to power data centers at the end of the day. And we need to talk about the end of life of IT hardware, because toxic materials that are built into the IT hardware, and the IT hardware is then shipped to the global south and is dumped there, not only has social impacts on the people working and living there, but also on the environment again. And there are two main levers that we can apply to increase the sustainability of IT systems generally, and I will soon come to AI-specific things. We need to better utilize the available hardware, so we need fewer hardware in total, and we need to increase the longevity of hardware so that we don't always buy new server racks or smartphones every 2 or 3 years, because there is a lot of actual carbon emissions and environmental impact already embedded into the physical hardware. And we, of course, need to talk about electricity. We need to use fewer electricity and especially cleaner electricity. And those trends combined together with all the environmental impacts lead to numbers of about 4% of the world's carbon emission that comes from the IT sector, which is roughly the same as world's farming emission. People always tell us we should try to avoid aviation because it's not sustainable. Well, aviation actually makes up only for 3% of world carbon emission. But we as AI engineers may ask ourselves, why should I care? Quality so far hasn't included sustainability. But my thesis here is that in the future, due to regulatory requirements and customer demands, sustainability will actually be part of our quality definition for systems. Same as maintainability, as security, as observability for systems is a quality requirement in the future. AI systems also need to be sustainable and not harm our environment. And there are 4 main areas that we can focus on that are distinct for AI systems where environmental impact happen. There are many things in IT generally that we could talk about on how to make IT systems and maybe web front ends more sustainable, but I want to focus on the specific aspects of data and AI in this case. And the first area that we should focus on is, of course, data. Data needs to be captured, needs to be transferred, loaded, cleaned, aggregated, labeled, tokenized, and stored. And all those processes, of course, take energy, but also physical storage hardware in order to store the data. Second area that we need to focus on is experiments, because the development phase of AI systems is just more resource intensive than with traditional application software, because we iterate, right? We try different models, we have different configurations and hyperparameters and data sets, and we do it over and over again. So this number crunching and this experimentation of trying to come up with appropriate solutions just takes up more resources than developing a web front end and running it on some occasions to see if the pixels are in the right place. Which is not to say that web development is not complex, but the impact from AI systems development is just higher. We also have more options there because in the experimentation phase, we already have the technology selection. So we can actually opt for more sustainable solutions, which I will talk about later. So we have talked about data and experiments that distinct the AI engineering process from the typical software development process when we talk about sustainability. The third is, of course, the training. Yeah, you've maybe heard that models like GPT-3 emitted about 550 tons of carbon, which is the equivalent of about 30,000 trees. And this is only a tiny fraction of the whole footprint of the model, because if we look at the data that is publicly available, the training of AI models often only accounts for about 10% of the emissions. The other 90% usually or often come from the inference, even though a single training session is very, very, very resource intensive, because we use the model so often and do so many inferences, the accumulated sum of energy consumption for all those inferences actually account for more resource consumption. This is the four distinct areas: data, experiments, training, and inference. And I will now provide some examples of what we can actually do to improve the sustainability in those four areas. And coming back to data, you've maybe heard about the fact that about 73% of all data stored will never be used again. So I think, in my opinion, it's a no-brainer that we need to have better data policies in place to actually review what data should be stored and under what circumstances it should be deleted again, right? Every data that I store should actually have a tag which says this is the point in time when this data will be deleted again. And we should also think about how we can make data broadly available, because if we already invest the resources in storing and maybe cleaning up data, it is better used if we provide it to more users and actually get more value out of it. So we have a better balance of value to sustainability impact. If we already talk about data and data storage, you should also consider opting for cold storage, especially if it is not time-critical data that is only infrequently used for training, for example. It is always cheaper to have them stored on a device that is not constantly powered. And of course, data quality. I mean, every AI engineer will tell you that good data quality is ideal, and we should all try to get good data quality. But on the other hand, we know that it's easier said than done. But it has a particular impact for sustainability, because if we train models on bad quality data, we'll actually have more energy consumption. So you have to balance the efforts that you take for cleaning up the data, getting the data in good state, and maybe should even invest more into the cleaning, even though the cleaning itself may take up some resources. From a sustainability perspective, it will always pay out. And I guess in most cases also for the output quality, right? And if we talk about model selection, everyone knows from our first statistics class, Occam's razor, if there are two equivalent options, we should always go with the easier one. So for us, this would mean maybe, taking 5 if statements and not the fancy LLM API just because it is there, right? Data centricity over model centricity, looking at the problem, finding the suitable solution instead of just using cutting edge new models just because they are there. So we've talked about those 10% of emissions that are produced during the training phase of the typical or average AI model. But there are, of course, differences. There are many kinds of models, and there are actually benchmarks out there. I just have one on top of my mind from the UMass University, where they have benchmarked different models for, of course, performance on the prediction results and whatnot, but also for the energy consumption. And you can easily see that different model architectures actually came up with pretty similar results, but different amount of emissions. So if you have the choice, you can, of course, or you should opt for models that have a lower footprint during training phase. And of course, I mean, we talk about AI engineering here. We don't talk about just using existing APIs because, well, this is just application development. But reuse is still good. And if there is a pre-trained model which is suitable for our need, it's just, I mean, financially a no-brainer, but also from a sustainability perspective, if we can reuse resources that have already been invested is always the better choice. We have many more options when we talk about models. We can also optimize the storage formats. There are different file types, and some of them take more data, more space to store them and to transmit them. And especially if we have different model versions, it is always worth considering the data format and how long we really need to keep models persisted if we have newer versions. And if we then talk about the training of models, we should, of course, opt for hardware optimized solutions. So please don't train your models on your CPU. And if you have available, use a GPU or maybe even more advanced chip generations. And please don't train your models locally. Like, even if you have a GPU available, in most cases, the hardware in the data centers will be much more efficient, energy efficient, unless you have maybe video stream data that needs to be processed and transferred, because also the data transfer itself via the network, of course, takes energy. But if you only talk about numeric data, time series data, it is usually the better option to transmit it via the network, do the training there, and just get the model back. When we already talk about training, there's actually one fancy approach that is actually applied also by Microsoft for many different applications, which is called time shifting. So it is basically planning to perform resource-intensive processes to times when there is plenty of renewable energy available, which maybe means that I don't train my model immediately, but just wait till noon because the sun is shining and the wind is blowing then. And we can actually cut the emissions of our models by up to 70% when doing that. And those things are actually quite easy to predict. And if we are being honest, most training of machine learning models is not time critical. They are usually integrated into our MLOps pipeline. They are automatically triggered. They are automatically integrated. So there is nobody waiting for the model to being trained, except if you are still in the experimentation phase. But if you do frequent retraining, which is another topic, you should, of course, ask yourself, is the retraining really necessary in my case? Because I've seen teams retraining their models just like frequently every week, just because there's new data available. But asking them if they have evaluated the performance, if the new data actually makes the predictions better, and they answered no, I think this is at least the first thing that you have to do, to evaluate the performance before you do retraining, because in many cases, new data doesn't improve the prediction quality. And then we talk about inference. I've already said inference makes up for about 90% in the average AI model of the emissions from the model. And taking the example of traffic monitoring, imagine you've trained a model that is able to recognize car templates. And this model is then applied on basically all car stations or car monitoring stations in the country. So you have one model, you have thousands and thousands of cameras, and they produce thousands and thousands of pictures. So the accumulated value of all those pictures that get passed through the model during the inference is just higher. And I mean, you could apply same principle to an algorithm or a model that detects hate speech or community violation in social media. And there are models that are differently efficient in the inference, like taking K-nearest neighbor and support vector machines. For certain use cases, they provide or they produce pretty similar results. There are also benchmarks about that out there. And if I can choose the model that has lower inference cost and due to economies of scale, this will definitely pay off. So coming to an end with the takeaways, if we are already in the inference phase, you should always at least consider distributed architectures. There are pros and cons. You still have the data transfer to the data center, but especially doing inference is often more sustainable doing on the client device, because if I have anything that must be classified and I first need to send it to a central data center just to do the inference there and then send the result back, it's maybe worth considering just doing the inference on the local device. And last but not least, of course, caching, because not everything needs to be passed through a model, right? If we have similar or the exact same data, we don't always need to put this data through the model, but we can just store the question and store the result, put it into a database, and querying a database will not only be cheaper, but also more sustainable compared to, again and again, inferencing the model. And we, of course, need to talk about measurability, because those are just some things that you can do. There are many other practices and activities that you can do to make your machine learning, make your AI systems more sustainable. But the very crucial part is that we also measure what we do. And there are different approaches on how to measure sustainability of IT. And I think one of the easiest, maybe oversimplified approaches, I have linked you here, is the calculator for the emissions of your models. You can just select the hardware type, how many hours you have trained, the provider, and the region. Region is important because, yeah, different energy mixes. And I think this is the first step you should at least take. This can still be wrong by a factor of 3 or 4, depending on the region or on your data. If you want to take it a step further, you can actually use open source libraries. This is AI specific, the experiment impact tracker. I mean, measuring sustainability of AI systems is not trivial. There are whole groups of people trying to improve measurability of IT sustainability because digital infrastructure is just so complex, right? If I would have to quantify the environmental impact of this video stream, I would not only have to do life cycle assessments for my monitors and my PC, but also my router and the internet backbone and the data center. So this is really just a calculation, not a real measurement. There are more libraries that you can use that actually dig deeper, where you can look into CPU, GPU usage, especially for the training phase, bandwidth and disk, and those metrics combined will often show you hotspots in your system where you can improve. So last 2 slides, coming back to the beginning, we want to apply machine learning for things that are useful, ideally create more sustainability in the world. So I want to ask you to use your capabilities, maybe not to build the next model that predict where you can buy the cheapest gas at a gas station, but maybe better utilize your talent to enable circular economy or to enable the energy grid transition. And I hope that you got a brief idea of what can actually be done to create more sustainable AI systems. And I think the main point here is that sustainability is not always more costly or creates more effort. I think bottom line, sustainable software systems and sustainable AI systems are also more quality systems. They are better to maintain, they are more performant, they are more cost efficient, and they are more sustainable, and therefore contribute to living worth future for every one of us. Thank you for listening.
Fantastic. That was a brilliant session. Thank you so much for sharing that. It was really on point, like specifically about data and AI as well. Our audience is obviously sort of heads down in that space right now. So it was I honestly, sitting behind the screens over here, I was fascinated by even just some of the simple stuff we were saying, like, you know, for example, I don't do my washing in the middle of the day when the cost of energy is so high. I'll do it at night because I'm you know, obviously encouraged to do so because of the cost of it. It's exactly the same thing, right? Like if I'm in no rush to train a model, of course I should do it in the middle of the night. Like it's a perfect way to think about it. Especially as you said, per region, because then I was like, oh, if it's global, is that tricky? But actually, if I'm hosting it in a European region at night, it's still obviously going to be sort of less used. So yeah, I'm very, very impressed. Thank you so much for sharing all of your different insights around that. Just a quick question, how do you often go and speak to customers about this kind of stuff? Like, would you say you design this in a bit like security for AI or responsible AI? Like green should be the third pillar, right? That is discussed early doors.
Yeah, it is exactly my comparison that I always use. I say think about security, right? You don't go and make a system secure afterwards, but it's something that you have to build in from the beginning, ideally, because then it will not be so costly, and then it will like be just a round concept. And I think it will be a pre-requirement for every system in the future to have a certain degree of sustainability, right? Not every software or AI system needs to be the most sustainable system out there, but it has to reach a baseline of sustainability as it has to reach the baseline of security today.
Yeah.
Yeah, I totally agree. Yeah.
I think it's probably as well, like, I don't know if I'm finding excuses here for my own usage, but it feels so far away when you're using it in data centers and things like that. It literally just, you know, the idea of it is you feel like you're just doing it on your laptop just for you know, pretty small scale, but actually the scale of what is actually happening and what we can just do from our laptops at home on our Wi-Fi, you know, our home Wi-Fi, it is incredible, and it removes it slightly. So I really appreciate you coming to kind of, yeah, just keep that top of mind for everyone. I think that was kind of been a nice addition. Yelle, where, if we want to go and learn more, because I feel like you've definitely really inspired me to think a little bit more about it, what would you suggest we go and do next after this talk?
So I was invited to this talk through the Green Software Foundation as a substitute for someone else who planned to give a talk today. So of course, the first address you should consider is the Green Software Foundation. It's a nonprofit focused on greening the IT sector, especially with a focus on software. And there are many great initiatives and communities out there. Another one which is closely related is climateaction.tech. It is a little broader. It is not so institutionalized, where you can just find peers, discuss ideas, start projects together. And if you want to apply machine learning for sustainability, you should definitely check out climatechange.ai.
Okay, great. I haven't heard of that one before.
No.
I know the Green Software Foundation, of course, but I will definitely check it out.
Fantastic.
Yeah.
Well, thank you so much for your time, Yelle. We really appreciate you stepping. Yes, you did step in at the last minute as well. So
Yeah,
thank you
thanks
so
for
much,
that.
because that was a great last minute talk. Hopefully you'll join us again in the future if we run another one of these.
Thanks for having me, and try to make your AI models more sustainable in the future.
Yes.
We will. Thank you very much. We'll see you later.
Bye.
Bye-bye.
Okay, with that, so, you know, definitely food for thought. We'll go to a little break and then we'll come back with our next session.